Hey, how's it going, everybody? Victor here. It's been a while since I shot my last video. And the reason for that is because I have a new job that I absolutely love. I'm working for a service provider here in Florida. Um, well, I guess that's pretty much the reason for this video. Um, Working at a service provider, you get to see a lot of stuff that you wouldn't normally see, like if you're on a regular routing and switching Cisco track. Um, in a service provider, you get to see a lot of MPLS, layer 2, layer 3 services and stuff like that. So that brings me to why I put together this video. And as I was trying to put together this topology, I run into some issues. And well, I guess I could have done this way more easily on GNS3. The reason I didn't do that is because I've had some troubles um, trying to put up my XRVs in GNS3. Um, on the other hand, on here on UNL or Unified Networking Lab, I can put as many XRVs as I want, and so I guess that's a good thing. Alright, so if you're like me and you're fairly familiar or not familiar at all with MPLS and layer 2 and layer 3 VPNs, uh, basically what's going to happen is that what you see here in the middle, that's our MPLS core. That's what's going to be for now. And then the two routers pointing towards the customers are the PEs, or the provider edge routers. And so typically in a, say, layer 3 VPN, what's going to happen is more likely you're going to have a internal BGP peering between your two PEs, and then you're going to have a external BGP between the customer router and the provider edge router. And so on this side, you're going to have a route distinguisher. Also, that this is called the attachment circuit, the circuit between the customer and the provider. So in the case of layer 3, you're going to have a route distinguisher or a BRF instance to, well, actually you're going to have both, to be able to distinguish the traffic between the different customers. So that's what's going to happen on layer 3. You're going to create a BGP peering. You're going to, I guess you're going to use some distributed lists, or that's something you could use to try to filter out some of the routes that you don't want to advertise to some of your clients or your customers. And so traffic comes in, goes across the MPLS, comes out the other way, boom, gets to the other customer or the other end of the customer. And before we even go any further, I'm going to show you that right now, how the MPLS works. So let me pull up the... So I already have everything configured here, and I'm going to be showing you my config, and we're going to pretty much we're going to go over it. So I'm going to do a show MPLS LDP bindings, and the loopback interfaces that I use to establish the LDP peerings, or the label distribution protocol peerings, are the loopbacks of every router. So as you can imagine, 2.2.2.2, 1.1.1.1, 4.4.4.4. So if we're going to go to router 4, here's the the local binding. Our label coming out is going to be 20,003, and then when it hits router 1, it's going to be 16,000, and from there we're just going to pop it out and push the packet down to XRV4. So that's what's going to happen. You're going to hear that a lot. You're going to hear a lot about swapping out labels, popping labels, and pushing labels. So XRV2 is going to push label, which is going to be 2003, if we're going to go to 4.4.4.4. When that packet comes in router 1 on this interface, um, it's going to swap it out, but before he does forward it down to router 4, he's gonna pop the label and transfer packet so router 4 can forward it to the to actual destination without any label, because that's the end of the MPLS core right there. So I'm gonna do a capture here on 000 interface, and we're gonna be able to look at that. So excuse me. So router 2. This time we're gonna do a actually let's do a trace route to 4.4.4. And then if you see, the label that we pushed was 16,000, and then let's do a ping. Stop the capture. Look at the ICMP packets. MPLS label, MP multi-protocol label switching header 222, label 16,000. Okay, that's here on the 000 interface. Now let's look at the other interface. It's the one. So and I realized I should have done this at the same time, but no worries. Do it again. Alright, so as the packet comes out, look at this. No MPLS header. Okay, so that's pretty much how MPLS works. Um, so before we look at the actual configuration, let's. We talked about layer 3 VPNs. Now, when it comes to layer 2 VPNs, well, what's gonna happen is um, well, I guess let me just go ahead and show you this. Um, Alright, so point-to-point layer 2 services, which is what we're gonna be kind of looking at right now. If you look at this, most of these most of these are just features of the um, layer 2 VPNs, and so pseudowire grouping, pseudowire load balancing, redundancy, multi-segment, pseudowire. Pretty much multi-segment is for when you have different autonomous systems within the core or across different cores. So for that you would use multi-segment pseudowires. Um, so what's gonna happen on the layer 2 VPNs, in this case point-to-point services, is that we're gonna have a pseudo wire going across the two provider edge routers. So in this case we're gonna have a pseudo wire going from this interface 0002 to 0002 on router 4. So these two interfaces pointing to the customers are going to be layer 2 interfaces, and so customer A on this side is going to be able to be as if they were on the same segment as customer A2. So pretty much this is going to become, these two routers are going to become a switch. So they're going to have layer 2 reachability. So in order to achieve that, this is what you're going to have. Alright, so you want to make sure that you enable router your IGP, or in this case Ospf, across your core. So make sure you advertise your loopback, because you're going to be using your loopbacks to create LDP adjacencies. So pretty much enabling autoconfig and MPLS sync, LDP sync within the IGP. Um, so pretty much that make sure that whatever you have your IGP enabled, then your MPLS LDP is also going to be enabled on that interface. Moving down to the layer 2 VPN configuration section. Um, Again, just stating our router ID is going to be 4.4.4. Actually, you know what? I'm looking at the wrong. Well, because I'm showing you router 2 and I'm looking at router 4 config, but no worries. Here it is, same thing. Um, okay, so OSPF. Oh well, here, this interface right here is gonna be layer 2 transport, and then look at this. .1 key VLAN 1010. Regularly you would use like something like encapsulation.1q and then save 1010, right? But I did that and then I keep running into troubles trying to get my pseudowire up, and the reason for that is because of the XRV image. I found this trying to Google it. Some guy said 2 years ago XRV does not support layer 2 VPN data forwarding yet. So, or actually, that's not the issue. Well, this is an issue because the thing is that I'm not gonna be able to show you how a ping goes across this within the same LAN segment, and it is because of this. So this was 2 years ago. I'm using XRV 5.2.0, I believe, and still that's not supported. I wasn't able to actually transfer traffic across that or forward traffic across that core. Um, what I had, hold on, I'm trying to, okay. So somewhere here should be the statement. Alright, so I kept running into troubles trying to get my pseudowire up, and it was because of this. The sub interface pointed to the customer. I was issuing this command encapsulation.1q100, and then I saw a post on the Cisco forums. Somebody said that he found a way around that, doing a .1q VLAN 100 instead of the .encapsulation.1q. So that's just so you know, if you try to make this work, you want to make sure you have that. So that's just an issue with the XRV image itself. So again, router Ospf, make sure you have MPLS auto sync and auto config enabled. Um, moving on, the actual layer 2 VPN section. Um, so we pretty much tell layer 2 VPN services that we want to use router ID 2.2.2. Then we create an XConnect group. This is just a name that you give to the group, and then this is a name that you give to the the point-to-point group, or the point-to-point pseudowire that you're gonna create. So in this case, I'm gonna assign the interface going, or the sub interface assigned to this customer within the point-to-point pseudo wire, and then we're going to create a neighborship or an adjacency with router 4. This is the loopback of router 4, and then the pseudo wire, it could be any number you want. I remember what's the range. Just make sure that it is the same across the two pseudo wire ends. And the interworking IPv4, pretty much we're telling the pseudo wire that we want to transfer anything over that pseudo wire. So that will be any transport over MPLS. Um, as I look at this, I realized that we don't even need this. This is just saying creating a static LDP appearance. But for that we have the sync and auto config for the OSPF. MPLS label range table. Remember when I did that trace and we look at the MPLS labels? Routers 2 labels all began with 2, and routers 1 began with 1, and so on. So that's pretty much what you would use the label range for, just so you can remember exactly what labels belong to what routers. So that's pretty much that. Again, on the router 4 will be the same config with the corresponding IPs and numbers. Um, what's going to happen on switch 9 is that we're going to have a trunk going to the PE just so we can for any VLANs, and then on the specific ports going to the customers we can do a access port with the corresponding VLAN. Or if they might have different VLANs, more likely we're gonna have a VPLS service, and so for that you would also use a trunk. So on router 5 and router 7, we're gonna say 192.168.10.1, and then what .10.2, and then you can see they're both on the same segment and they will be able to communicate with each other. Um, Sadly, we're not gonna be able to see that right now, but I'm gonna show you the if we do a show layer 2 VPN XConnect and then do a detail. As you can see, the pseudowire is up. The group is VLAN 1010. The X connect or the pseudowire name is VLAN 1010. The attachment circuit, which is a circuit between the customer and the PE, is um, terminates in subinterface 0002.1010, which is up. Um, let's see what else we have here. We can also do a show MPLS or show layer 2 VPN X connect, and then pretty much tells you the status of the pseudo wire, the uh, the other end of the pseudo wire, and the VLAN. If you had another or a redundant pseudo wire, you would have the segment 2 description. Down here, you would see the redundant pseudo wire, and then it's gonna be the status always gonna be down because pretty much what you have is a failover, not as much as a kind of forward packets within using both pseudo wires. You wouldn't have that. You would have something more like a failover in which one's going to be up all the time. Then in case that goes down, then the other one takes over and uh, go from there. So that's pretty much how that would break down. Um, So what I'm gonna try and do next is that I'm gonna be trying to look at all these different features and stuff. Obviously, I have a long way to go, uh, but for now, this is point to point. So later, we're gonna be looking at multi-point layer 2 services or VPLS, which is way more interesting. What's gonna happen is to be honest, I don't remember if I mentioned it. Um, with VPLS, we're gonna create virtual forward instances across all different PEs, and instead of having a pseudo wire between these two PEs, we're gonna have. Let me pull up the. So instead of having this pseudo wire here, we're gonna have pseudo wires going to all PEs, so kind of like a full mesh. And so within each PE, you're gonna have something called VFI or virtual forwarding instance, and in each VFI, you're gonna create pseudo wires to all the different PEs. So this is gonna be a huge switch, and then what's gonna happen is that you're gonna be able to start looking at you're gonna start seeing a lot of spanning tree again and layer 2 protocols, and it's because customers are going to be able to start doing broadcasts in their uh, LAN segments. So that's what's going to be happening. Mm, I guess for now I don't have much more to show you. Um, but definitely this is something that I didn't think I was going to be doing for now. I thought I was going to be focusing on my starting for my CCIE. That's something I wanna achieve in the near future. But this is very exciting. I think I'm really enjoying this for now, and I guess that's all. I hope this has been in any way informative for you, and well, I'd like to thank you for viewing.